All right, this is the notes video for slides 17 and 18. All right, so determine the value of each limit without graphing. All right, so remember the first step in solving any limit problem is to substitute in the number that we are approaching, right? So we're approaching -3, so we're going to evaluate when x is -3. So 3 over -3 plus 1, all divided by, let's see, -3 squared minus 9. All right, so we do that. 3 over -3 is -1 plus 1. -3 squared obviously is +9 minus 9, right? So -1 plus 1 is 0 over 0. Of course, we get 0 over 0, right? Which is uh, always the case when we are doing one of these factor and reduce problems. Remember, sorry, not always the case, but that is what we expect to get most of the time. All right, so now what are we going to do? This one doesn't really look like a lot of others. It looks kind of weird because we have this 3 over x. All right, so what we need to do is, well, we need to adjust this so that we don't have that 3 over x. Now, one important thing to remember is because this x is in the denominator, x equals 0 is restricted from the domain, right? So we can't have x equals 0. But remember, if x is approaching -3, -3 is, far away from 0, right? When you think about it, right? Because remember, when we're approaching -3, we're getting close, like -2.9, -2.99, -2.999, which is nowhere near 0. So that's not an issue. All right, so anyway, what we're going to do is we're going to multiply the top by x and the bottom by x. Okay, now what does that do? Well, remember, if I have the 3 over x plus 1, I distribute that x. Now the x is reduced and I'm no longer stuck with that x in the denominator. But remember, you want to make sure that you carry down the limit as x approaches -3. All right, and so now I'm going to distribute the x in the numerator. All right, and so I get limit as x approaches -3, and I have 3 plus x, right? If I distribute here, the x reduces with the first one and then plus, and then I have to distribute the x there. And then in the denominator, I'm not going to distribute that. Why not? Well, we know that ultimately we're going to need an x plus 3 in order to factor and reduce, right? Because when I plug in -3, I get, 3 plus -3 is 0. So we must have the same thing in the denominator. So I don't want to distribute the x because we know we're going to have to factor. All right, so limit as x approaches -3. All right, so I have 3 plus x in the numerator. I have the x, and then the x squared minus 9 is the difference of two squares. So x plus 3 and x minus 3. Now, remember, we've talked about this before. 3 plus x and x plus 3 are, in fact, opposites, but 3 minus x and x minus 3 are not the same, so we cannot reduce those. All right, so if I do that, I'm left with the limit as x approaches -3. And remember, we do have a 1 in the numerator, and then I have x times x minus 3. All right, so now we reevaluate, and I get 1 over -3 times -3 minus 3. All right, and so -3 minus 3 is -6 times -3 is 18. So 1/18 is our answer. All right, next one. Okay, this is just another example, but now this has more square roots in it. So we are going to multiply by the conjugate of the denominator. Now, of course, we should plug in first, right? So 2 minus 2 divided by root 2 minus the square root of 4 minus 2, right? So 2 minus 2 is 0. 4 minus 2 is 2. So I have root 2 minus root 2. Of course, we get 0, right? So then we're taking the existing x minus 2 and multiply by the conjugate of the denominator. So that would be root x plus root 4 minus x divided by, and now in the denominator, root x minus root 4 minus x, and then root x plus root 4 minus x. All right, and so now what should we do and what should we not do? We should multiply out the conjugates. So in this case, we should multiply out the denominators. We should not multiply out the numerator. Why? Because remember, we're plugging 2 in, and so 2 minus 2 gives us 0. So we know that we're going to need x minus 2 ultimately to reduce in the numerator and denominator. All right, so limit as x approaches 2. I do not multiply out the numerator, so root x plus root 4 minus x, but I do multiply out the denominator. All right, so root x times root x is just x. All right, then I have this minus root 4 minus x times root x and plus root 4 minus x times root x. And so those would actually subtract out. And now I have a minus root 4 minus x times a plus root 4 minus x. So remember, that means we're going to have a negative, and then I have root 4 minus x times root 4 minus x, which is 4 minus x. Now, it's very important that you use parentheses around the 4 minus x because remember, okay, if I do a little work on the side, I just had root 4 minus x times root 4 minus x. Of course, this becomes 4 minus x, but the problem is that one of them was negative and one of them was positive. And so when I multiply those, I have a negative 1, right, for the coefficients times the 4 minus x. And so that means that we have to remember to distribute that 4 minus x, right? All right. And so now I have the limit as x approaches 2 of numerator stays the same, x minus 2 times root x plus root 4 minus x. All right, and then the denominator, what does it become? Well, if I distribute that, I get minus 4 plus x. So I actually get 2x minus 4, right? And so what did we say we needed to happen earlier? We said we needed an x minus 2 to reduce, right? So you notice the denominator can be factored further, right? So limit as x approaches 2 of x minus 2 over root x plus root 4 minus x. And then I have 2 times x minus 2. So now, of course, I get the x minus 2's to reduce. And so I'm left with the limit as x approaches 2 of root x plus root 4 minus x divided by just 2. All right, and so now we reevaluate. Root 2 plus root 4 minus 2 all over 2. And so 4 minus 2 is 2. Root 2 plus root 2 is 2 times root 2 over 2, of course, then just root 2. All right, and so that is example number 2. All right, let's move on to slide number 18. All right, slide 18. All right, once again, same idea. We want to evaluate with negative 2. So I get negative 2 cubed minus negative 2 squared plus negative 2 plus 14, all divided by negative 2 plus 2, right? All right, so negative 2 cubed, remember that means negative 2 times negative 2 times negative 2, which is negative 8, minus negative 2 squared, so that would be minus positive 4, right? So minus 4, all right, and then minus 2, and then plus 14. So negative 8 minus 4 is negative 12, minus 2 is negative 14, plus 14, of course, gives me the 0 that I expect. And then in the denominator, of course, 0. So 0 over 0 is what we expect, right? Now, but remember, you want to make sure that you are doing that each time so that you are, in fact, getting 0 over 0. Because remember, if you don't, then that means that you do not continue with this method, all right? So now, what do we need to happen? Well, we know that if I plug negative 2 in, I get 0 in the denominator and I get 0 in the numerator. And the only way that that is true is if x plus 2 factors out of the numerator. And so what we want to do is we want to use synthetic division to divide x plus 2 out of the numerator. All right, and so remember, put the negative 2 there, and then I put 1, negative 1, 1, 14. And remember, bring down the 1. 1 times negative 2 is negative 2. Negative 1 plus negative 2 is negative 3. Negative 2 times negative 3 is positive 6. 1 plus 6 is 7. 7 times negative 2 is negative 14. And then we get 0 as the remainder. Remember, we were expecting to get 0 as the remainder because we knew that x plus 2 needed to factor out. Now, what if it didn't? What if we didn't get 0 as a remainder? Then maybe we made a mistake up here where we were plugging in negative 2. And then that means maybe we didn't actually get 0 over 0. So those are things that you can do to kind of check your work if something isn't working out the way that you expected it to. All right, so that means that I have the limit as x approaches negative 2, and I have x plus 2 times, remember what's remaining, 1, negative 3, 7. So that means 1x squared minus 3x plus 7, all divided by x plus 2. So now my x plus 2's reduce, and I'm left with the limit as x approaches negative 2 of x squared minus 3x plus 7, all divided by 1, right? And so we don't necessarily have to write that. So then I'm going to reevaluate with -2. So I get -2 squared minus 3 times -2 plus 7. All right, so -2 squared, 4 plus 6 plus 7, right? So 10 plus 7, 17, right? So 17 is my answer. All right, so that